Wait, so this video is going to talk about the monopoly equilibrium. So we have our model of monopoly. The last video did show how we could get the marginal revenue curve for the monopolist. So once we have that, we have the graph drawn here as we're going to need it. We have the market demand curve. We have a monopolist. They're the only firm selling this product. They face the entire market demand curve. We now know what the marginal revenue curve looks like for this monopolist as well. We've got an average total cost curve and a marginal cost curve drawn in here. For perfect competition, the cost curves were sort of like on a different graph than the market demand curve because there were many firms in the industry. So the cost curves for the firm were small. We had small quantities relative to the quantities for the market demand. But for the monopolist, we have it all on one graph. So we only need to have one graph here. And for the monopolist, well, the monopolist is a for-profit business, so they are trying, just like any other business, to maximize their profit. To maximize profit, the rule for maximizing profit is to find the quantity where marginal cost equals marginal revenue. A firm wants to continue producing or expand output up to the point where marginal cost is equal to marginal revenue. So that was why we had to first off figure out what the marginal revenue curve for the monopolist looks like. And now we've got the marginal cost curve drawn in. It's sort of like a normal, familiar kind of cost curve for the firm here. We've got a U-shaped average total cost curve, and then we've got a upward sloping marginal cost curve. So all we have to do is find the intersection of the marginal cost, marginal revenue. That's simple enough. They intersect right here. And this is going to be the quantity. That's the monopoly quantity. I'll call that QM. That's the quantity that's going to maximize profit for the monopolist. The other thing we have to see is, well, what's going to be the price of this good in the market? We don't go straight over to the price axis to get the price. We have to figure out, because the price has to come off of the demand curve. The demand curve, after all, tells us the quantity that consumers want to purchase at different prices. Or it would tell us what the price would have to be if you're going to sell a certain quantity of the goods. So we take this QM and we have to project up to the demand curve. It hits it here, and then we project that price, we project this point over to the vertical axis, and that's going to be the price that the monopolist charges, PM. That's going to be the price that will maximize profit for the monopolist. The other thing we can show on this graph is the amount of profit that the monopolist earns. Profit is just equal to, well, we can write that out as follows. Profit can be written out like this. Profit, we often use a symbol pi for that, is price minus average total cost, that quantity times Q. When you're multiplying two numbers together, graphically, that's the equivalent of taking an area. So we're multiplying two numbers together, we've got a rectangle. And the bounds of that rectangle are going to be price and average cost. So the quantity there is going to be the QM, the quantity that the monopolist is going to want to sell. So the other thing we have to do is, well, what's the cost per unit when the monopolist is operating here? Well, that's given off the average total cost curve. So we project up from QM until we hit the average total cost curve. We hit it here, and then we project over to the horizontal, or to the vertical axis here, and then this rectangle then would be the profit. So we can shade that in here. And there's the profit. So we've been able to identify the profit maximizing quantity, the price that the monopolist will charge with their maximizing profit, and the area of profit that they have. In perfect competition, we had a short-run equilibrium and a long-run equilibrium. In monopoly, we just have one equilibrium. This is really effectively the long-run equilibrium. And the reason for that, the reason why we don't have a separate long-run versus short-run equilibrium in monopoly versus when we did in perfect competition, is that in perfect competition, the thing that changed in the long run was we had entry of firms. Firms could enter the industry. The assumption that we have in the monopolistic model is that there are barriers to entry. There's one firm selling the good, and there are barriers to entry. No other firms can enter the industry. So if this was a competitive industry, or if in the absence of barriers to entry, if there were no barriers to entry, this monopolist would be making an economic profit. That's like a really good party. And so other people in the economy, other investors would want to crash this party. They would start businesses to compete with this monopolist and compete the profit away. That's why we could say in the perfect competition, in the long run, well, entry has to come to an end. So that gives us a zero profit condition for a long run equilibrium in a perfect competition. And that could be different because in the short run, firms could be making either a profit or a loss. So in the long run in monopoly, well, there is no difference. So if this was a short run equilibrium, this would end up being a long run equilibrium as well, because there is no because of the barriers to entry, no entry of firms can enter into the industry. So whatever is the short run equilibrium, if you want to think about it that way, is also the long run equilibrium. We don't have an entry dynamic that could give us a long run equilibrium condition that would be different from what we could see in terms of balancing of quantity demand and quantity supply in the short run, like we in perfect competition. So with this, we would be done. One thing to note is that I've drawn in here where the monopolist is making a profit. There is nothing in our assumptions of the model of monopoly that guarantees a monopolist would make an economic profit. It just simply depends on where the market demand curve is relative to the average total cost curve. In this case, because the market demand curve lies above the average total cost, this monopolist would be able to make an economic profit. It's possible that a monopolist could make a zero economic profit. It's also possible if the demand curve was below the average total cost curve, that the monopolist would make a loss. Now, there would be a case where we might see a difference between a short run and a long run equilibrium. If the monopolist was making a loss in the industry, which is entirely possible, and they have a graph in the book that shows that. I'm not going to do a video on that specific case, but it's entirely possible you could have a monopolist that would be making a loss. They'd be maximizing profit, but still making a loss. In the long run, we would not expect that monopolist to stay in the business. They would go out of business, and that product would simply not be produced. So you probably, if you had a monopolist making a loss, and then we'd have to say, like, well, if it was a loss, not because, like, say, the market demand was temporarily low, and in other words, that the market demand curve was where it was expected to be, costs weren't necessarily high for some short-term reason. If that was where we were expecting it to be, well, the monopolist would probably exit the business, get out of this business, go do something else with these resources, and that good wouldn't be produced. So that would be the one case where you'd have something that probably you could show a monopoly equilibrium and the monopolist is, quote, making a loss, and that probably won't be the long run equilibrium, because if no firm is going to voluntarily choose to make economic losses in the long term. But here it is. Here's our monopoly equilibrium. We only need one graph. We only, in effect, really have one equilibrium. We don't have separate short run or a long run equilibrium. So the monopoly outcome here is a little simpler than what we had in perfect competition.